Hi, this is Math 6, Unit 5, Lesson 7, using diagrams to represent multiplication. So let's use area diagrams to find products. First of all, kind of a warm up here today, we estimate the product here. It says for each one of the following products, choose the best estimate of its value and be prepared to explain your reasoning. So we have 6.8 times 2.3. If I'm looking at this, what I might look at in terms of estimating is say, well, this is about 7 and this is about 2, so 7 times 2 is probably going to be about 14. I look down here, I have 74 and 8, so I know I'm having 8 groups of 74, so it's definitely bigger than 5.6, definitely bigger than 56. I'd go with 560, and as an estimate I might think of this as being 70 times 8, which gets me down there as well. Over here I can see that this is about a tenth, right? This is 900ths, which is pretty close to a tenth, pretty close. So I know that I'm taking 166, and if this was 1/10, I multiplied it by 0.1, I'd simply move the decimal over one spot. So I'm going to estimate that it's probably about 16.6, based upon that being about a tenth. Over here, this is about 2. And this is 3.4 times 2, or about 2. So we're looking at something close to 7 or 6.5 is probably going to be good enough there. So again, what do you see? What do you notice there? It's about 2. Just estimating. Again, the whole point of this was just to estimate and explain why you think it is what it is. Alright, activity 2 is another optional one, but we'll look at it anyways. It says here are 3 ways of finding the area of a rectangle that is 24 units by 13 units. So 3 different ways of finding an area of a rectangle is 24 by 13. So we take a look at these 3 shapes here. We know it's a 24 by 13 rectangle, and these are 3 different ways to take that rectangle and divide them into smaller portions in order to figure out the area of these shapes. The next question I ask you, want you to talk about, are what are some things that these pictures all have in common, or how are they alike, and then also how are they different. And so what are some things you notice your partner for how they are alike and how they are different. So go ahead and talk about those things with your partner, about what do you see between the 3 pictures that make them similar and what makes them different there. Okay, just conversation there. Alright, so hopefully you've had a conversation there. Maybe you might notice that of course they're the same rectangle, they're the same shape. Right, that's similar. They all have the same area. When you add all this up and add those up and add those up, you end up with the same area. The differences are going to be the way that they are decomposed, right? This is 20 and 4, so you take the 24 and break it up that way. This one broke the 13 up into 10 and 3. This one kept the 24 like it was, and this one kept the 13 like it was. So different ways of decomposing those things there. The question I want to know for part C is, if you were to find the area of if you find the area of a rectangle is 37 units by 19 units, which of the 3 ways of decomposing the rectangle would you use? So let's say you had to draw a new rectangle that was 37 by 19, right? So you take this here, 37 and 19, and you had to draw one of these again. Hey, Stevie G's here to visit. Hello, friend. Sorry, Stevie G the kitten is here. Hello. Here's Stevie G's paw saying hi. Hop down, buddy. There you go. I've been gone a few days, so he misses me a little bit. So, if you were to decompose this, what might you do? You might break this up into a 30 and a 7, like that. And you might break this one up into maybe a 10 and a 9, and then you'd have 4 segments there. You might do it differently. This might be a simple way of doing the 37 and 19. You end up with 300 there, 30 and 9, makes 270 there. 10 and 7 is 70, and 7 and 9 is 63. So we have some easy numbers to add up together to find out what the total area is going to be by adding those up, putting back together. 14 plus 6 is 20, and we have 3, 4, 5, 6, 7. So end up with 703. That's what I end up there. I don't know if that's right or not. But there we go. So there might be a way of doing it there. So perhaps you want to decompose it by having 4 sections, kind of like diagram 1. Maybe you want to do something different. I don't know. 19 and 37 aren't numbers I'm used to working with, so I'd probably break up a little bit more if I had to do that. Okay. You may be familiar, number 2, with different ways to write multiplication calculations. Here are 2 ways to calculate 24 times 13. And so 24 times 13, this is what we call partial products, all right? So we're going to do long division in our next lesson. I think it's the next lesson. Look real quick. No, more products in the next one still. So partial products means we take a look at each piece and we put them into their own little section. So for example, we look at 3 times 4 as being just 3 ones times 4 ones for a total of 12 ones. We look at 3 times 2, not as 3 times 2, but actually 3 times 20. Okay, because this is in the tens place, this is 3 times a 20. Alright, so that's how that you get up with 60 there. When I look here, this is actually not 1, this is 10 times a 4, which is a 40. And finally over here I have a 10 times, oh, not times Stevie G. Oh goodness, Stevie G. You are just in a mood, aren't you? 10 times 20, because that's a 20 there, for a total of 200. So what's happening here is this is like taking your square, right, and breaking this apart into a 20 and a 4, as well as a 10 and a 3. This is what a partial product is doing. We're putting these into sections. 4 and 3 is the 12. 3 and 20 is the 60. 4 and 10 is the 40. And 20 and 10 is the 200. That's partial products. And what I do as a result of all that is then I will take, I'll move my stuff here for Stevie G to have a place to sit. Oh goodness. Here, sit right here, buddy. And I can add those up to find out that I have 312. Okay, right there. And so when you combine them here, here's calculation B. Calculation B said, well, they have 72 and 240. That's what they have here. So how'd they get a 72 and a 240? Notice that these combine to make 240. These combine to make 72. So there's something they're doing here that's a little different. Okay, so we have 240, which is across this way, and 72, which is across this way. So I would say in calculation B, what we're looking at possibly doing, there's only 2 sections here, is you probably have the 24 here, and a 10, and a 3. And the reason we say that is because 24 times 10 is 240, and 24 times 3 is 72. So those are the 2 partial products. There's one method here, and one method there. So now let's take a look at calculation discussions here. With your partner, in calculation A, how are the partial products obtained? For instance, where does the 12 come from? Again, we talked about that, so have a conversation there. In calculation B, where is the 72 and 240? Where do they come from? And then, look at the diagrams in the first question. Which diagram corresponds to calculation A? Which one goes to B? So calculation A, this is like diagram number 1 with the 4 boxes. And this one seems to go with diagram number 2 with just the 2 boxes from our earlier discussions there. So how are the partial products of calculation A and the 72 and 240 in calculation B related to the numbers in the diagram? Well, those numbers are related to the different areas inside of each box. So 240 and 72 are the 2 partial areas there combined to make the whole. And over here, these are the 4 different partial areas combined to make the whole there as well. Let's take a look at number 3. Use the 2 following methods to find the product of 18 and 14, then compare the values obtained. Alright, so calculate numerically. Alright, so calculate numerically. We would look at this and say this is 4 times 8, which is going to be 32. 4 times 10, right, this is 10, which would be 40. 10 times 8, which is going to be 80. And 10 times 10, which is going to be 100. So this is going to be just doing the partial products method, right? So that becomes a total of 2 there, 8, 12, 13, 14, 15 there. We carry the 1, and we have 252. So that worked out okay. Okay, you might have also seen it with long division before, but we're doing the partial products here, so that's why I did it like this. Here's a rectangle 18 by 14. Find its area in square units by decomposing it. So you might decompose it by doing 18 can break up into 10 and 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can break that apart right there. Alright, so I have 10 right here. And I have 8 right there. And the 14, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right here and draw a line across there so that I have a 10 here and a 4 there. So there's 10 and 8 for 18 and 10 and 4 for 14. So in total, I have 100 here. 10 times 8 is 80 there. 10 times 4 is 40 there. And 8 times 4 is 32 there. Compare the values. 18 times 14 that you obtain using two methods. If they're not the same, check your work. Let's take a look here. Well, I have a 32 and a 32. I have a 40 and a 40. I have an 80 and an 80, 100 and 100. So everything matches up the same there, and we know we have the correct answer. Okay, awesome. Let's do activity number 3. All right, connecting area diagrams to calculations with decimals. You can use area diagrams to represent product of decimals. Here's an area diagram that represents 2.4 times 1.3. And we can see we have the 2 and the 0.4. We have the 1 and the 0.3 there. Find the region that represents 0.4 times 0.3, which is 0.4, 0.3, and label it with an area of 0.112, or 12 hundredths. Label each of the other regions with their respective areas. So 1 times 0.4 is simply 0.4. 2 times 0.3 is going to be 0.6. And 2 times 1 is going to be 2. Got it? So we find the value of those. Well, to find the value of the area, I can combine all the different small areas. I can do 2 plus 0.4, 0.6, and 0.12. We can put some zeros here to hold our place values and line them up nicely. So 2, we have 11, carry the 1, and a 3, and decimal point goes there. So 3.12 when I add up each of the individual areas there. Okay, we could also multiply 2.4 times 1.3, and we could say let's multiply this by 10 to get 24, and we can multiply this by 10 to get 13, and 24 times 13 is 312. Now I multiplied everything by 10 times 10 is 100, so now let's divide that by 100, which moves it 2 places to the left, so we get 3.12. So it's another way of multiplying that out and showing your reasoning. Both methods work just fine. So here are two calculations of 2.4 times 1.3. Analyze the calculations and discuss the following questions with a partner. And so we can see here we have partial products, which definitely correlates to our area diagram up above. We can see our 0.12, 0.6, 0.4, and a 2. And then we have this partial product, which is a 0.72 and a 2.4. Okay, and we can see the 0.72 showing up right here in this row, so it's a combination of that, and the 2.4 showing up as a combination of that there. So in calculation A, where does the 0.12 and the other partial products come from? Okay, well that comes from the breaking apart the 2.4 into 2 segments and the 1.3 breaking it apart into 2 segments there. In the calculation B, what we can see is we're taking the product and we're saying let's take our 2.4 and we're going to keep it as our top number, and we're going to break the 1.3 into a 1 and a 0.3. So that gets you a 2.4 there in that area and a 0.72 in that space. Oops, sorry. in that space there. So this is what's happening in calculation B. That's how that's being broken apart. In each calculation, why are the numbers below the horizontal line aligned vertically the way they are? So below the horizontal line, why are they aligned vertically? Well, we line them vertically in each of these, below this line here, in order to make sure that our place values line up the right way. When we're doing partial products, we want to make sure we're adding things up along that decimal point. So that's why those are there. So the digits line up, the place value, it's easier to add things up when you line them up like that. Okay, let's look at number 3 real quick. Find the product of 3.1 times 1.5 by drawing and labeling an area diagram and show your reasoning. Okay, so let's just draw a little area diagram here. 3.1, we can make that as a 3 and a 0.1. And 1.5, we can make that as a 1 and a 0.5, like so. Now, we can do 3 times 1 is 3. 1 times 0.1 is 0.1. 3 times 0.5. Well, 3 times 5 is 15 and 1 decimal, so 1.5. 1 times 5 is 5, but I have 2 decimals, 2 numbers behind the decimal, 1, 2, so we're going to go 1, 2, so 0.05. So the product would be the sum of all those things. So 3 plus 1.5 plus 0.1 plus 0.05. And again, lining up our columns here, we have a 5. 5 plus 1 is 6, decimal point, and 3 plus 1 is 4. So that's our product of 3.1 times 1.5 using an area diagram, how you would show that. Show how to calculate 3.1 times 1.5 using numbers without a diagram. Okay, so how do we do it without using a diagram? Well, again, we could do 3.1 times 1.5, and we think about this as being 5 tenths times 1/10, right? So this is 1/10 times 5 tenths, which equals 5 tenths, which is going to be written as, in our case here, we could say just 5. Okay, we can write 5 tenths right there. Now we have 5 tenths times 3. So this is 5 tenths times 3, which is going to be equal to 15 tenths, which is also 1.5, like that. We're good so far? Maybe? What did I do here? Oh, sorry. Back it up again. Got ahead of myself. 10 times 10 is 100. This is 5 100ths. So sorry. I knew something was a little off there. Back that up. Ching ching. Fix that. 0, 5. Now this is 1 times 1/10, or 1 times 1/10, which equals 1/10. That would be 1/10, like so. And this is 1 times 3, which simply equals 3. So now we add these up. We have a 5 here, we have a 6 here, our decimal, and 4.65. And so that works out great. Okay? Again, this is using partial products. Long division is something you might have learned before, and we'll get that in a couple lessons, but this is using partial products here. Alright, I'm going to skip Are You Ready for More? And move down to number 4. This again is an optional activity which you may or may not have done in class. It says label the diagram to represent 2.5 times 1.2 to find the product. So let's do our 2.5 up here. So here's 2.0 and 0.5. This will be our 1 and our 0.2 right there. Okay, so those are our regions there. Now we're going to label the areas with the A, B, C, D with their areas. So 2 times 1 is 2. 1 times 0.5 is still 0.5. 2 times 2 is 4, but I have to move 1 decimal to the left, so this becomes a 0.4. And 5 times 2 is 10, but I see I'm moving 1 to the left, 2 to the left, so I'm going to go 1, 2, and up with 0.10. So there's our areas there. And when I find the product there, which is part C, I'm going to add them up. So we have 2 plus 0.5 plus 0.10 plus 0.4. So that becomes a total of 3, which is question part C to that same question right there. All right, so 3. Number 2, Here are two ways to calculate 2.5 times 1.2. Each number with a box gives the area of one or more regions in the area diagram. So where was our point 1? What area was that in? We look back at our picture. Let me get the right page here. And the point 1 is over here in A. Point 4 is right here in region B. Point 5 is here in region C. And then D is our last region right there, that one. Okay, A, B, C, and D. So where do you find the 0.5 region at? Well, 0.5 is going to be when you combine A and B together. So A plus B. And the 2.5 is going to show up when you add C and D together. C plus D right there. Okay, so those are the letters that correspond to the regions here. In calculation B, which two numbers are there, and that's what, okay, so we got it all done there. So that's how you end up with that. Okay, let's look at the next section. This is a little longer one in terms of pages, that's for sure. So our summary for the day, before we get on to today's homework, says that we can calculate the product of any two numbers that are written in base 10, and we can do that with using base 10 numbers and areas of rectangles. And so we can take our units at 3.4, 1.2, we can break them apart into smaller sections, like so. And then we can combine those things to find out what the total area is going to be. So there's different ways of finding that area. This is with the partial products, okay, doing each one by itself, or we can take a look at doing one at a time, okay. So this becomes the 3.4 times 2, which is 0.68, and this is 3.4 times 1, which is 3.4. So different ways of showing that there, but you still end up at the same spot when it's all said and done. Okay, so we're going to pause there to give you some time to work on your homework, okay, and then we will come back together and check it in a few minutes. Okay, Math 6, Unit 5, Lesson 7, homework help here, using diagrams to represent multiplication. So here's a rectangle that has been partitioned into 4 smaller rectangles. For each expression, choose a sub-rectangle whose area in square units matches the expression. Okay, so we have 3.4 in total and 2.6 in total here, which means if I'm going to break this apart, instead of having 3.4, I would make this whole section 3 and this whole section 0.4. And over here, instead of having 2.6, I'd make this larger section 2 and make the smaller section 0.6. Okay, that's how that would be broken apart. So 3 times 0.06 is going to be right here where those come together. That's going to be in part B. 0.4 times 2 come together here in part C. 0.4 times 0.6 come together here in part A. And 3 times 2 come together right there in part D. That'd be the best way of drawing that out if you were to do that. Okay? Here's an area diagram that represents 3.1 times 1.4. Find the areas of subrectangles A and B. Okay, so for A, it's 3.1 times 1, which is simply 3.1. For B, it's 3.1 times 0.4. Okay, maybe a little different there. So 3.1 times 0.4, I could think of this as multiplying by 10 to get 31, multiply this by 10 to get 4, and then I could do 31 times 4, and 31 times 4 is 124. Now, I multiplied both by 10, which is a total of multiplying by 100, so 124 divided by 100 means to move the decimal 2 places to the left. So we have 1, 2, 4, and we go 1, 2 to the left, and we end up with 1.24. So what is the area of the whole thing? Like we did there. We have, the whole thing. This part right here is 1.24. That's B, is 1.24. A is 3.1. So the area of all of it is to combine those up. We have 3.1 plus 1.24. So we end up with 4.34 is the total area, which is not on the screen. All right, number 3. Draw an area diagram to find 0.36 times 0.53. Label and organize your work so it can be followed by others. Sure. So let's take this here and break this up into different sections. So instead of 0.53, let's draw this as 0.5 and make this 0.03. And over here, let's make this a 0.3 and a 0.06. Now again, we do this because it gets us numbers that we can use, we know a little better. 5 times 3, for example, is 15. I have 2 digits behind the decimal, so I'm going to move this over 1, 2, to put my decimal there. 3 times 3 is 9. I have 1, 2, 3 digits behind the decimal, so I'm going to go 1, 2, 3, decimal point, and I have 2 little loops there, which means I need to put 2 zeros there, 0.009. 5 times 6 is 30. But notice I have 1, 2, 3 behind the decimal, so I'm going to go 1, 2, 3 behind the decimal, so I get 0.030. And 3 times 6 is 18, and I have 1, 2, 3, 4 digits behind the decimal, so I'm going to go 1, 2, 3, 4, decimal. I have 2 zeros to put in place, and there we are. Okay, so that's an area diagram and how I would solve that. If I had to solve it, it doesn't ask me to, but maybe you did. And then I could add those up, 0.15, 0.009, 0.030, and 0.0018. And if I add that up, I'd have 8, 10 carries a 1, 8 and 1 is 9, and 1 there. So it has an area of 0.1908. Doesn't ask you for that, but maybe you did it anyways, and you want to check and see. Good job if you got it right. All right, number 4. Find each product. Again, different ways of solving this. So let's go ahead and look at this as it's the same as multiply by 10 to get 25. Multiply that by 10, which moves the decimal 1 space to the right, gets you 14. And 25 times 14 is going to be 25 times 14. Interesting. So 25 times 14, again, maybe something you know or don't know. I'm going to look up on my calculator real quick just to verify, because I did it a different way before. So 25 times 14 gets you 350. Now we moved it to one to the right and another to the right, which is to the right, because that's combined times 100. So we're going to divide that by 100 to move it 2 to the left. So we write a number, 350, and move 2 to the left, which means 3.50. So that's A. For B, to move 2 to the right, I multiply by 100. To the right, multiply by 100. Okay, that could work there. And so that's a total of multiplying by 4 zeros, 10,000. So then it was 64 times 81. Again, maybe not ones you want to work with there. I could break this apart. We could do like we just did with the area stuff, right? We could think, well, let's not do all that mess. Let's do 60 and 4, and let's do 80 and 1. Okay, so 6 times 8 is 48 with 2 zeros. 8 times 4 is 32 with 1 zero. 60 times 1 is 60, and 4 times 1 is 4. So now when I add these up, we add all that up, we end up with 4, 8, 11, 5,184. But I got here by multiplying by 1,000, meaning I moved the decimal 1, 2, 3, 4 to the right. So now I want to divide by 1,000 to move it back where it belongs. So I move 4 to the left. So 1, 2, 3, 4. So we have 0.5184. Okay, so it's a good combination of lots of methods we've been using so far to show you how that one works for 4B. All right, number 5, complete the calculations. So something plus 4 equals 5, let's go with 1. 3 plus 6 is 9, and 2 plus 7 is 9. That works. Okay. Adding here, so what plus 4 equals 2? We're going to have to go with 8, because 8 plus 4 is 12, so we carry the 1 there. So now 1 plus 6 plus 3 is 10, and 1 plus 2 is 3. I got to get to 9, so I need 6 more to get to 9. Over here, 7 plus 5 is 12. 1 plus 3 is 4, plus 1 more is 5. And I have 4 by itself here, so 4 plus 2 more makes 6. That'll work. To get to 4, I have to do 14. So I think about 6 plus 8 is 14. 1 plus 5 is 6, plus 3 more is 9, and then 1 plus nothing is 1, and we leave it right there. And number 6. Number 6, which are the last one for the day. Diego bought 12 mini muffins for $4.20. Good job, Diego. 12 muffins for $20. At this rate, how much would Diego pay for 4 mini muffins? Okay, so to go to 4, moving here to 4, that's dividing 12 by 3. So divide 420 by 3. 3 goes into $4.20. Goes in there one time, which is 3. 3 and 4. We have $1.40. Okay, so it's going to cost $1.40 for 4 muffins. How many mini muffins could Diego buy with $3? Alright, so yeah, let's say he has $3. Well, we know that he can get more than 4 because $1.40 gets you to 4. Okay, if he doubles the $1.40, now you're talking about 8 muffins, right? You're at $2.80. If you double this, let's say this is times 2, and times 2. Now you're at 8. We're at $2.80. The question is, can he get to 9? That's something we don't know right now, right? We can't really tell if he can get to 9 or not. It's hard to say. So we need to see, can he add another muffin there or not? We know we can get 4 for $1.40. How much for another muffin, like a 1 muffin? That's the question. So while it was not helpful to double it and go, cool, I know we can for sure get 8. The question is, can I get 9? Let's see how much it takes to go get 1 muffin. Let's take our 4 here, and let's divide by 4 so we know what 1 muffin is going to be. So I take my $1.40 and divide by 4. So $1.40 divided by 4 is going to tell me my price for 1 muffin. 4 goes into 1 0 times, goes into 14 3 times with 12. We subtract and have 2 there. So it's 35 cents a muffin. So if he was to buy 9 muffins, 9 would be $2.80 plus 35, which is 5, 8, 9, 10, 11. Carry the 1, $3.15. 9 muffins is going to be $3.15. That's too much. So we would say that Diego can only buy 8 muffins, and he'd have a little bit of change left over. All right, that's it for today. Have a great day, and we'll see you next time.